Have you been confused about writing SPDF electronic configuration? Hi everyone, welcome back to the channel Chemistry Simplified with Rosaline. In today's lesson, I'm going to be showing you an ultimate trick in mastering how to write SPDF electronic configuration. Grab your pens and your jotters and let's dive in. The SPDF electronic configuration. There are 4 atomic orbitals in an atom: the s orbital, the p orbital, the d orbital, and the f orbital. There are arrows pointing from one orbital to the next. The arrows are pointing to the backward direction for a reason, which we will find out as we proceed. Now we are going to number our atomic orbitals. The s orbital 1, p2, d3, and f4. Again, we need to know the number of electrons each orbital can accommodate. The s orbital can accommodate a maximum of 2 electrons. The p orbital 6 electrons, the d orbital 10 electrons, and the f orbital 14 electrons. Guys, now listen attentively because this is where the trick comes in. Let's go back to our rectangle. In our rectangle above, we have 4 atomic orbitals: the s, the p, the d, and the f orbitals. Let's start with the first orbital, which is the s orbital. In coming out with our trick, above 1 we have seen just s. That is the first series of orbital we'll be working with, and we are going to write each of the series twice, meaning we are going to write s and s again. We write and repeat. We are going to have our s and our s. That's the first series of orbitals we'll be having. Now that we have had our first series of orbitals, let's move to the second. Now, let's move to orbital 2, which is the p orbital. Above 2 in the rectangle, we have seen that we have the p orbital. Now, there's an arrow pointing from the p orbital to the s orbital. That says that after writing the p orbital, you have to go back again and write the s orbital. So what are we going to have? We are going to have our p, and then we are going to have our s. We are going to write ps. That is our second series of orbitals, ps. And of course, we remember that for each series, we are going to write it twice, meaning we are going to have ps and ps. I repeat, we are writing twice, meaning we are going to have ps and ps. Hope it is clear. Let's continue and come out with the series for the third orbital. Above 3, which represents the third orbital, we have seen the d orbital. In the box, in the rectangle, above 3, we have seen d. So we are going to come out with a series for the third orbital. What do? We begin with letter D. We have seen that there's an arrow pointing from letter D to letter P. We begin from D, come to P. Are we ending at P? Of course not. There's still an arrow pointing from P to S. So our orbital, the next series of orbitals we'll be having are DPS. I repeat, DPS. That's the next series of orbitals we'll be having. And of course, we know that we are not writing just that. We write and repeat DPS, DPS. If you have been following attentively, at this point, you should be able to come out with a series of orbitals for the fourth orbital. Let's continue with 4. Above 4, we have the F orbital. So we are beginning with F. From F, the arrow points down to D. From D, it points down to P. And from P, it points down to S. So the series of orbitals we'll be having are the F, the D, the P, and the S orbitals. And of course, we remember that we are not writing just that, we write and repeat. We write the series of orbitals and then we repeat them, meaning we write them twice. So let's write the F, the D, we go down to P, and we go down to S, and then we repeat that series again. F, D, P, and lastly S. That's good. We are going to continue with numbering of the various orbitals. We have so many orbitals here, the S orbitals, the P, the D, and the F. Now in numbering, we start with the S orbital. The S orbital is the first orbital. So in numbering them, we start with 1. We number from 1 till the end of the orbital. And then we go to the P orbital. In numbering the P orbitals, we begin with 2. And in numbering the D orbitals, we begin with 3. And numbering the F orbitals, we begin with 4. We are going to see what I'm saying as we proceed. Let's do the numbering. 1, 2, 3, just the S orbitals. 4, 5, 6, 7, and 8. So we have 8 S orbitals. We are going to number the second set of orbitals, which are the P orbitals. Remember that we begin from 2. So we have 2P, 3P. We are beginning from 2 and then we go to 3. And then we go to 4. That's the next P, which is 4. After 4, we go to 5. Where is the 5th P? Yeah, that's 5 there. And after that 5, we are going to look for the next P. Is there another P orbital? Yeah, there's another P orbital. That's the 5th P orbital. And then we have the last one, which is the 7th P orbital. So we have 7 P orbitals. But remember, we began with 2. We started with 2, not 1. After the P orbital, we move to the D orbital. And remember that the D orbital begins with 3. We start numbering from 3, meaning we are going to number 3 and 3, 4, 5, and so on and so forth till the end of the orbitals, till all the D orbitals have been numbered. So let's do that. That's 3, 4, 5, and 6. We continue by doing same for the F orbital, beginning with 4. We have 4. Beginning with 4, we have 4 there. That's 4F. And the last one, we have 5F. And we are done with the numbering of the orbitals. This is our ultimate cheat formula. By using examples, let's see how we can use this our formula to calculate or to come out with the electronic configuration of any element on a periodic table. Let's have examples. The very first one we will be looking at is sodium. Sodium Na, from the Latin name natrium. We know that sodium has 11 electrons. The atomic number of sodium is 11. Therefore, there are 11 electrons in the sodium atom, or the sodium atom has 11 electrons. Let's see how we can distribute these electrons and then come out with the electronic configuration of sodium. Remember again that the remember that the s orbital takes a maximum of 2 electrons, the p 6 electrons, the d 10 electrons, and then the f 14 electrons. So let's start. We have the s orbital that takes a maximum of 2 electrons. Those are the electrons we have given to the first s orbital. We continue with the second s orbital. It still takes a maximum of 2 electrons. Those are the 2 electrons that we have given to the second s orbital. Now we are going to the next orbital, which is the 2p. We know that the p orbital takes a maximum of 6 electrons. So we have given 6 electrons to the p orbital. If we take 2 plus 2 plus 6 is going to give us 10 electrons. So 1 electron is still pending. Let's continue. We are going to give the 1 electron to the 3s, even though we know that the maximum number of electrons the s orbital can take are 2 electrons. But since we have just 11 electrons and just 1 is left, we give the 1 electron to the s. So the 3s will be 3s1. And since the last electron is found in the s orbital, what does that tell us about sodium? Sodium is an s block element. Example 2. Let's look at bromine with 35 electrons. Let's fill that quickly. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. It is as simple as we are seeing it. The principle is same. S taking a maximum of 2 electrons, P accommodating a maximum of 6 electrons, D accommodating a maximum of 10 electrons, and F accommodating a maximum of 14 electrons. Let's look at the next example, which is chromium. There's an exception with chromium and copper when it comes to this electronic configuration. I'm going to explain as we proceed. Now we are filling our electrons. 1s2, 2s2, 2p6, 3s2, 3d6, 4s2, and 3d4. Normally, this is what we expect, but guys, it is wrong. It is not correct, and I'm going to explain why. But first, let's have the correct one. So the correct one is going to look like this. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d5. This is the correct way of filling for chromium. This way of filling gives extra stability or more stability to the chromium atom. Look at the 4s orbital and the 3d orbitals. You discover that they are half-filled, and half-filled subshells provide more stability to the atom than completely filled. Like the first case, we have 4s2, which was completely filled, and 3d4, which was not completely filled and was either not half filled. So this configuration of 4s1 half filled and 3d5 half filled provide more stability to the atom. Here we draw the curtains for today's lesson. It was nice having you on this space, Chemistry Simplified with Rosaline. If this video has been helpful to you, please click on the notification bell and also subscribe to this channel for more tricks related to chemistry concepts, and I will see you in my next video. Bye bye.